Data almost never arrives ready to use. It shows up messy and in the wrong shape for the question you want to ask. Here is a tiny table straight from the source, and already it is a mess. An age is missing, a name is lowercase, where the others are capitalized. And look closely at that 22 in quotes. It is stored as text, not a number. Feeding this straight into an analysis would give you nonsense. Data transformation is the work in between, reshaping, cleaning, and converting raw data into a form your analysis can actually trust. It sits at the heart of every data pipeline. There are two classic ways to arrange this pipeline, and they differ only in the order of three steps. The first is ETL. Extract the data from the source, transform it while it's in transit, and only then load the clean result into your warehouses. Transform happens before loading. The modern alternative flips the last two. ELT. Extract. Load the raw data straight into a powerful warehouse and transform it there, in place. Cheap storage and fast warehouse have made this the favorite today. You load first and reshape later as many times as you like. Let's actually clean a table. Here is the raw version. Now with the fourth row, and it has four separate problems hiding in it. Cleaning means hunting each one down, then rebuilding the table properly. Problem 1. Duplicates. Rows 2 and 3 are identical. The very same record entered twice. A clean table keeps just one copy. 1. Rohan, not 2. Problem 2. Inconsistent formatting. The name is lowercase, and so is one city. We standardize the casing, so Rohan and Delhi match the rest. Otherwise, the same city counts as two different places. Problem 3. Wrong type. May's age is stored as text, the string in quotes. We must cast it to a real integer, so we can actually do arithmetic on the age column. And problem 4. The missing age. We have choices. Drop the row, fill it with a constant or impute. Replace it with a sensible estimate, like the average of the ages we do know. 20 and 22 average to 21. Now apply all four fixes at once and rebuild. The duplicate is gone, the casing is fixed, the age is a real number, and the blank is filled with 21. Same three records, but every cell is present, correctly typed, and consistent. Analysis ready. Now the most important reshape of all, the pivot. Here is a sales table in what we call long form. One row per combination. A month, a product, and the sales figure. 6 rows, 3 columns. It's tidy, but hard to read. To compare tea against coffee month by month, your eye has to hop all over the column. A pivot fixes that. It turns the distinct values of one column into columns of their own. Watch it happen. Month becomes the row label. The two products, tea and coffee, become the two new columns. And each sales number flies to the cell where its month and its product meet. 30 is Jan tea, top left. 50 is Jan coffee, beside it. 40 and 20 are Febs too. 10 and 60 are Marches. Every value lands in exactly one cell. Because every month and product pair is unique. And there it is. The same 6 numbers, now a clean month by product grid you can read in a glance. Long went to wide. That is a pivot. But here's the catch you must never forget. What if two rows map to the very same cell? Look, two Janti rows, 30 and 20. They both want the same slot. The pivot cannot hold both. So a pivot must aggregate when cells collide. You choose a rule, sum them, or average them. And that one number goes in the cell. Sum here gives 50. Silently dropping one of them would be a bug. Every reshape has a reverse. Melt, also called unpivot, runs the pivot backwards, collapsing columns back into rows. Take one wide row, January, with tea 30 and coffee 50. Melt splits it into one row per product. The column name becomes a value in a product column. The number becomes a value in a sales column. One wide row unfolds into two long rows. Pivot and melt are perfect opposites. Next, aggregation. Group and summarize. This collapses many rows into a few summary rows, exactly the group by you met in the query lesson. Take the full long table again and total the sales for each product. Tea appears in 3 months, 30, 40, 10, summing to 80. Coffees 50, 20, 60 sum to 130. 6 rows shrink to 2. That is aggregation. A whole group crushed down to one summary number. Last reshape. Joining or enriching. Often the column you need lives in another table. Here are grouped sales sit above a separate prices table, both keyed by product. A join brings a column across on the shared key. Matching on product, tea's price 15 joins onto tea's sales, coffees 25 onto coffees. And now that price sits beside sales, we can even compute revenue. 80 times 15 is 1200. 130 times 25 is 3250. Richer data, ready to analyze. Here's a tension at the center of data engineering. The shape that's best for recording data is the opposite of the shape that's best for analyzing it. On the left, the normalized shape from the transactional world. Facts are split across small linked tables. Orders here, customers there. So no fact is ever stored twice. Change Asha city once in one place. Perfect for fast, safe writes. On the right, the denormalized shape analytics prefers. Everything is pre-joined into one wide, flat table. Notice Asha's name and city now repeat across her two orders. That redundancy is accepted on purpose. Why? Because reads need no joins, so they fly. So the rule is a clean trade-off. Normalize for writes, no redundancy, safe updates. Denormalize for reads, accept redundancy, skip the joins, and query fast. Analytics stores lean hard toward denormalized, white tables. The star schema idea we meet next. One more family, and this one points ahead to machine learning. Models want numbers on a comparable footing, so a few transforms prepare the columns before they ever reach a model. 3 quick ones. First, scaling. If one column runs in the tens and another in the tens of thousands, the big numbers drown out the small ones. Min-max scaling squeezes a column into 0 to 1. Subtract the minimum, divide by the range. Min is 20, max is 60, so the range is 40. 20 maps to 0, 60 maps to 1, and 40, right in the middle, maps to 0.5. 0.5. Same information, now on a tidy 0 to 1 scale. Second, encoding categoricals. A model can't multiply the word red. So one hot encoding turns one category column into a column per category, holding a 1 or a 0. Red becomes 1 0, blue becomes 0 1. And third, binning, the reverse move. Instead of an exact age, group numbers into buckets. Young, middle, senior. It trades precision for robustness and turns a continuous number into a handful of clean categories. Scale, encode, bin. That's the prep that feeds a model. Your turn. Here is a long table of quantities: day, item, and quantity. Pause the video right now and pivot it. So the items, pen and book, become the columns with 1 row per day. Fill in every cell yourself before I do. Here's the answer. 2 days become 2 rows, Monday and Tuesday. Pen and book become the 2 columns. Now place each quantity where its day meets its item. Monday pen is 3. Monday book is 2. Tuesday pen is 5. Tuesday book is 1. Every pair is unique. So no cell collides. No aggregation needed. If your grid reads 3, 2, 5, 1, you have pivoted it perfectly. Trap 1. Mixing up ETL and ELT. ETL transforms before loading. ELT loads the raw data first and transforms it inside the warehouse. Modern stacks lean toward ELT. Trap 2. Forgetting a pivot must aggregate. When 2 rows land in one cell, You have to combine them, sum or average. Silently keeping just one is a real bug. Trap 3. Careless missing values. Dropping a row and imputing a value lead to different results. Choose on purpose and know what your choice does to the numbers. Trap 4. Applying the wrong shape. Normalize for writing, no redundancy. Denormalize for reading. Redundancy on purpose. They pull in opposite directions. And trap 5. One-off edits. A transformation should be a pipeline you can rerun on tomorrow's data. Never a stack of manual tweaks you can't repeat. And always recheck your data types after loading. Let's pull it together. Data transformation turns raw, messy input into analysis-ready output. The pipeline is extract, transform, load, or its modern flip, extract, load, transform. Cleaning removes duplicates, fixes wrong types, standardizes formats, and handles the missing values by filling or dropping them. Reshaping bends the table's very shape. Pivot long into wide, melt wide back into long, group rows into summaries, and join to enrich. And always aggregate when a pivot cells collide. Choosing the shape is a trade-off. Normalize with no redundancy for safe writes, denormalize into wide flat tables for fast reads. And a final family scales, encodes, and bins the columns to feed a model. All of it built as a pipeline you can rerun, not a one-off. Master these moves, and messy data stops being an obstacle. Next, we'll see the analytics store those wide, denormalized tables were built for.